Alright, so in this problem, I have 6 to the power of x is equal to 60. So to solve this, I'm going to first start by taking the log on both sides. So I have log 6 to the power of x is equal to log 60. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 6 to the power of x, and I can move x to the front. So now I have x times log 6 is equal to log 60. Now I'm going to divide both sides by log 6. So then these two cancel out, and now I have x is equal to log 60 over log 6. Now log 60, I'm going to rewrite as log 6 times 10. Now I have this over log 6. So if I have something in the form log of a times b, this is equal to log a plus log b. So log 6 times 10, that's going to equal log 6 plus log 10. And now I have this over log 6. Now this is the same thing as log 6 over log 6 plus log 10 over log 6. Now log 6 and log 6, these two cancel out. So now I have 1 plus log 10 over log 6. Now log 10, that's the same thing as 1. So now I have x is equal to 1 plus 1 over log 6. And log 6, we can rewrite that as log of 2 times 3. So now this is the same thing as log of 2 plus log of 3. And log 2, that's equal to 0.301. Log 3, that's equal to 0.4771. So x is equal to 1 plus 1 over 0.7781. Now 1 over 0.7781, that's equal to 1.2852. So 1 plus 1.2852 is equal to 2.2852. So this is my answer. Alright, so in this problem, I have x to the power of 4 is equal to 4. So I'm going to first start by subtracting 4 on both sides. So then these two cancel out, and now I have x to the power of 4 minus 4 is equal to 0. Now x to the power of 4 I can rewrite as x to the power of 2 times 2, and 4 I can rewrite as 2 squared. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, that's going to equal x to the power of 2 to the power of 2. Now I have this minus 2 squared is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 2. So I have x squared plus 2 times x squared minus 2 is equal to 0. So now this gives me two equations. I have x squared plus 2 is equal to 0, and x squared minus 2 is equal to 0. So for x squared plus 2 equals 0, I can subtract 2 on both sides, so then these two cancel out, and I have x squared is equal to negative 2. So now to solve this, I'm going to take the square root on both sides. Square root of x squared is x, and the square root of negative 2 is the square root of 2 times the square root of negative 1. Now if you guys already know, the square root of negative 1 is equal to I. So I have x is equal to positive or negative square root of 2i. Now for x squared minus 2 equals 0, I can simply add 2 on both sides, and I get x squared is equal to positive 2. Now to solve this, I'm going to take the square root on both sides. Square root of x squared is x, and this is equal to positive or negative square root of 2. So now I'm going to check. My original equation was x to the power of 4 is equal to 4. So the square root of 2 to the power of 4, because this is an even exponent, it doesn't matter if it is positive or negative, it's going to be the same result. The square root of 2 is the same thing as 1/2, so I have 2 to the power of 1/2 to the power of 4, which is equal to 2 to the power of 2, which is equal to 4. So this works, and for the square root of 2i, it's exactly the same thing. There's no difference. So my 4 solutions are right. Alright, so in this problem, I have 4 to the power of x is equal to 12. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 4 to the power of x is equal to log 12. Now if I have something in the form log a to the power of b, this is equal to b times log a, because all I have to do is simply move my exponent to the front. So for log 4 to the power of x, I can move x to the front. So this is going to equal x times log 4 is equal to log 12. Now we obviously want to isolate x here, so to do that I have to get rid of this log 4 by dividing on both sides. So then these two cancel out, and now I have x is equal to log 12 over log 4. Now log 12, that's equal to log 4 times 3. Now I have this over log 4. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 4 times 3, that's going to equal log 4 plus log 3 over log 4. And this is equal to log 4 over log 4 plus log 3 over log 4. Now log 4 and log 4, these two cancel out, so now I have 1 plus log 3 over log 4. Now log 4, that's equal to 2 squared, so I have x is equal to 1 plus log 3 over log 2 squared. And log 2 squared, that's the same thing as 2 times log 2. Now log 3 is equal to 0.4771. And log 2, this is equal to 0.301. So now I have x is equal to 1 plus 0.4771 over 2 times 0.301. And this is equal to 1 plus 0.7925, which is equal to 1.7925.